honor.
I was going to say he does have a Cleveland connection.
That's right. I wish this was the first in-person speech, and that you guys flew me out in the CAS jet that I've heard so much.
Yeah, right.
Sophia's not operating. You know, they're trying to look for people to use Sophia now. So
okay,
there you go.
Yeah,
think big.
So Brian is the distinguished professor of physics at the University of California in San Diego, and the whole, the whole story behind it, or some of the story behind the whole B mode thing. In fact, thought he was going to be in running for a Nobel Prize, but he didn't get the Nobel Prize. But he did. What the result was a really interesting book. Okay, and it's called "Losing the Nobel Prize." And this was my summer read this year when I went to Montana on my 2-week fishing trip, and I enjoyed every minute of it. It's a fascinating book. I was going to try to write some stuff down about it, and then when I looked at some of the reviews, I couldn't pass up Brian Greene's comment where he said, Brian Keating's riveting new book tells the inside story of the search for cosmic origins, emphasizing the influence of Nobel dreams and laying bare the question of whether the lure of grand prizes is ultimately a good thing for science. And he does a wonderful job of it. So I really, really recommend this highly. Okay, it's a good read, 300 and some pages, and it's a lot of fun. A lot of inside baseball stuff about the Nobel Prize and what have you. He also has a podcast that's quite interesting. So I'd suggest you check that out online. So you didn't come here to listen to me talk, but I'm going to listen to Brian talk. So with that, I'm going to turn it over to Brian, if you could welcome.
All right. Thank you, guys. Thank you, Gary's plural. And it's great to be back virtually in Cleveland, where my career began. And it began courtesy of one of the planets you guys just mentioned, which was Jupiter. And we'll get into that. And I was fortunate enough to end up at Case Western. 1989, first day of classes was my first day on campus, but it had such an enormous reputation from professional astronomers and from being in the news for things shortly before my matriculation in 1987A, the supernova in the Magellanic Cloud over there was discovered by a Case astronomer, as you guys probably know. And Peter Pesch, who is a grand, old and wonderful individual who really kind of inspired my academic journey. He was my freshman advisor. And so I have fond memories of Cleveland. I was back in 2018 for a book signing and a speech at the synagogue that's on campus. That was super fun. And today it's great to be here to talk about things related to the Nobel Prize. It is the Nobel Prize week after all. So it's like Christmas for nerds. And I just want to ask if you guys can see my slide with me pointing up the Cosmic Hall of Fame. Can you guys see that? I can't hear anybody saying anything, so it's dangerous to assume anything. Can someone unmute and let me know if you can see my?
We don't see it yet.
You don't see it. Well, I see what's happening here. So you'd think with 3 years of Zoom almost that a professor would be good enough at reviewing Zoom that he or she could actually perform this adequate. Now can you see it?
There we go.
All right. And you should see the next slide now, which talks about my group here in San Diego.
Yep.
Great. So yes, I am Brian Keating, and this is a great treat to be here back in Cleveland, at least virtually. Hope to come visit you before your 200th anniversary comes up. And this is really a treat. I mean, you guys do such phenomenal work, and Cleveland's such a phenomenal city. I really kind of regret that I wasn't a member of the CAS as a young scientist, but B, that I'm not there in person. As I said, that will have to wait until next time. For now, I'm in San Diego, where I have a large research group, which I share with another wonderful young professor, Cam Arnold, who's in the back. For some reason, he's 10 years younger than me, but has a lot less hair than me. I don't know why. But nevertheless, we have an amazingly competent and incredibly diverse and just enthusiastic group of young men and women from all over the planet. Literally every continent on Earth has been represented by people in my group. And I'm just so excited about that. We study the universe in all its glory at microwave and infrared wavelengths. And there's a website there, but I'm going to give you homework because I am a professor. I cannot resist giving you some homework here. So the first thing is, if you're watching on a computer screen, you can take out your iPhone, your Android phone, if you're a heathen, or Windows phone. Anyone got a Windows phone? Palm Pilot, anybody? Get a Palm Pilot. So take out your phone. I can see you all out there. And you can scan this with your camera app and it'll open up a website. And if you're watching this on your phone, you can actually go to your web browser and type in briankeating.com/list. And what I've been doing is giving away free samples of the villain of my book, Losing the Nobel Prize. The villain of the book, spoiler alert, I don't win the Nobel Prize in this book. In fact, nobody in this book wins a Nobel Prize. But B, the spoiler, the villain of this book is space dust, which also goes by the name of meteorites. And I have little samples of these meteorites, which are samples of failed planets in our solar system that are representative of the type of signal that we actually did detect. We thought instead that we had detected the aftershocks of the explosive Big Bang origin, so-called inflationary universe. But instead we were undone by this very, very humble substance called cosmic dust, or as I call it, space schmutz. That's the technical name for it. So if you join my mailing list, a very high chance of winning a very own signed copy of a meteorite from the deep innards of our solar system. So make sure you do that. You can do that by snapping that picture or by merely typing in that address, briankeating.com/list. And you have all sorts of goodies. I send out 2 emails a month, and they're pretty fun to write and hopefully fun to read. There's about 10,000 people that get them every week. For some reason, it is not letting me use my cursor to do it. And the last piece of homework for now is to take out your phone or your the computer and type in to YouTube, Dr. Brian Keating. That's my YouTube channel. And I love it if you
YouTube is online.
the computer in the back. I have a computer assistant. Computer, be quiet. So if you type in this into YouTube, you will get a request to join my YouTube channel. And there I put out 2 to 3 videos a week. And these are either explainer videos about interesting topics in cosmology, particle physics, from an experimentalist point of view. There's a lot of, you heard about Brian Greene from Gary, and he is a friend and future upcoming guest on the podcast. He blurbed my book so graciously, but he's a theorist, and nothing against theorists, but we need experimentalists, and we need to kind of champion what we experimentalists and my colleagues do around the world in particle physics laboratories, in dark matter detection experiments, and in cosmology experiments. So that's what I endeavored to do on my YouTube channel. So you can take a picture again, and it'll take you to YouTube, sign up, subscribe to the YouTube channel. And there you will get either explainers or interviews with, so far I've interviewed 14 Nobel Prize winners, including some that won just last year. And so you'll really benefit from their knowledge, maybe not so much from my knowledge, but not only do I try to get their knowledge and what they've done, but also their wisdom and their humanity, as well as their scientific and or technical accomplishments. So I've got 3 new interviews coming up with the winner of the Nobel Prize last year in economics, the winner of the Nobel Peace Prize for global warming in 2006, and also the winner of the Nobel Prize in 1997 in physics for Bose-Einstein condensate. So these are really fun interviews to do. I hope you'll join. Okay, this just shows you how you can do it. If you're kind of slow and you're using that Trio or that hand Palm Pilot from way back when, you just go over, click subscribe, and you're all set. Okay, so I mentioned dust, I mentioned space dust. And the interesting thing that I never thought I'd write a book. I never thought we'd really need me, your humble correspondent, to write a book about the early universe, simply because there was so much great knowledge that had already come from these great intellects like Brian Greene or Jana Levin or many, many other people. Lawrence Krauss, who was the department chair when I was at Case Western way back when. And so who needs me? But I realized, again, those are all theoreticians, and that it would be good to have an experimentalist point of view for the people that actually build the instruments, the telescopes, the detectors, et cetera, like my colleagues do. And to do that, I felt like I only wanted to tell a story if I was the only person on earth that could tell the story. And that's when it came to me to write this book back in 2018. which did receive a lot of great awards. No Nobel Prize for Literature, sad to say. So I'm still Nobel-less, but that's okay. I won Father of the Year 2 years running, which is kind of sad because my oldest is like 11 years old. But anyway, we have to make do with what we have. And I always got angry at these dust jackets. Whenever you get a book from the library, or you buy them, hopefully on Amazon, so my kids can go to Case Western someday. The covers fall off, they get dirty, and they get all messed up. And what's the point of these dust? I mean, how much dust is really raining down on people's, bookshelves on a daily basis? Very little. So I thought they were superfluous, unnecessary, boring, and a waste of time. Until I found out a couple of things about dust jackets. One is that if you have an ancient book, like I'll be showing you, from the man who introduced me to Peter Pesch and other people, and that is Jay Pasakoff. He told me when I had the copy in my hands, as you'll see in a moment, of Galileo's Sidereus Nuncius, that if that book didn't have its cover, it would be worth not $500,000 as his copy is worth, but something like, maybe $50,000. Still a lot of money, but nowhere near the value. And I'm not saying that so you guys will all scoop out many copies of my books, but nevertheless, that is one of the most valuable things, because people judge books by their covers, and without the dust jacket, you really don't have much. The second thing is that there isn't a lot of importance to dust in our universe, and it's really overlooked by many of my colleagues. So I mentioned Galileo a second ago. This is his own sketch of his little telescope, which is probably, about the size of some people's telescopes that are just joining and learning about the Cleveland Astronomical Society. I know my first telescope was about this size too. And it's really just like, a pirate would use. Here's my little demonstration telescope I keep here. But with this telescope, even from downtown Cleveland, Ohio, you can see all the wonders of space that Galileo himself saw floating over the Tuscan hillside back in 1610. And here's an example. On the upper left are these depictions, hand sketches in the Sidereus Nuncius, which is Latin for the sidereal or starry messenger, not to be confused with Neil deGrasse Tyson's book that came out last week. And Neil's coming back on my podcast next week, hopefully, for a second appearance about his book called The Starry Messenger. So you can steal books titles. I never knew that when I was hoping nobody else had my book titles, but it doesn't matter. You can steal their titles. But you see, in January 1610, Galileo was looking through this tiny little telescope, just like you can, and he saw all these wondrous sights, little stars going around Jupiter, as he later realized that there must be moons in orbit, satellites, which he named after his benefactors, kind of like, someone naming something after the National Science Foundation that they discover. We don't do that anymore. We name it after ourselves, or and now they're known as the Galilean moons. So he actually didn't have to be so arrogant, as he had a very healthy ego, which I'm coming to realize is not too uncommon, even among my Nobel laureate kind of guests on the podcast. But he also saw the craters of the moon, and he saw the ears, as he called them, of Saturn, that were later turned out to be discovered by Cassini and others as rings in orbit around the planet. And I found out, depressingly, that the observations that prove that the rings of Saturn don't orbit as a solid disk, those are made in Pittsburgh. I mean, if you can believe such a thing. Pittsburgh, it have to be Pittsburgh, couldn't it be Cleveland? Anyway, it was discovered at University of Pittsburgh, or Pitt. Anyway, he wrote this book. It got him great fame, instant fame. In fact, he never left Italy, what would later be called Italy, and yet his fame spread to every continent known to exist, except for Antarctica, which hadn't been discovered back then. But more on that later. He published a lot. Publish or perish. It applies to professors then as now. And these are just some of his books. But you see on the lower right is a book called The Dialogue, or Dialogo. And you see in the very beginning, in the upper left, was one of his first books. It's called The Compass. And it's not like a magnetic compass. It's a slide rule, like a protractor, basically. And you see that he writes down about these objects, but it's a military device, which it is. And this is in 1600. I believe that one is 1602. And then the next books, then you see in the next book, it's the Sidereus Nuncius. And then the next book after that, was a letter to the Grand Duchess of Tuscany. And there underneath his name, you see Academicio Linceo, which meant that he had been elected by virtue of his discoveries into what was then kind of the Nobel Society of that time. It was called the Academy of the Links. The lynx being this animal with big eyes that's very perspicacious. But so then all the rest of his books, he always writes down his name. You know, it would be like someone writing a paper that won the Nobel Prize and then keep saying that he won the Nobel Prize. But finally, he gets to the dialogue in the lower right. And if you look at the first, the Sidereus Nuncius, which was the first evidence for the Copernican universe, that is written in Latin. And that was allowed. He had been cautioned before that time to not teach the Copernican theory, but he was allowed to do research in it. Teaching meant speaking in the vernacular of the people. Well, the people didn't speak Latin then as now. And so it was okay for him and fully acceptable for him to publish many, many papers and books about this, except he was forbidden to teach about it. But he sort of seems to have forgotten about it or thought that his fame would make that obviate the need to publish in Latin. And so by the last 2 books of his life, he published those in Italian. And that's really what led to his undoing. The Dialogo means the dialogue in Italian, not in Latin. You see it on the lower right. That's the book that made the classic defense, as you all know, for the Copernican model. And it's entitled the discourse or the discussion, the dialogue on 2 world systems, one being Copernican, one being Ptolemaic or biblical on the left. That's what he was forbidden to do. And here I am with Jay Pasakoff at Williams College looking at his copy of the Sidereus Nuncius. It's quite breathtaking to hold a book that's worth more than, you know, my house or whatever. It's pretty fantastic, and he's very gracious to show that. And you see it there, and it got him into a little bit of trouble, as we know, although I hope to disabuse those of you who might be under the impression that he was tortured or really that he was imprisoned. I'll do that in just a second. But if you look at this object here, which you all recognize as the Pleiades, the 7 sisters, or if you have a certain make and model of Japanese car, it's called Subaru. Here's his sketch of that from the Sidereus Nuncius. Shows these 7 sisters. Actually, there's only 6 you can see. And he was sort of called by Edward Tufte the father of data science, because, or at least of data visualization, because in this image are 2 different types of stars. There are the open stars that look like stars of David, maybe, that he sketched. And those are stars you can see with your naked eye. And then there are the stars that you can only see with a telescope. And he thought all of the image of the Pleiades was completely resolvable and caused by individual stars. He just knew his telescope wasn't powerful enough to resolve them. So he said the following thing. He said, what we observed is the nature or matter of the Milky Way itself, with the aid of the spyglass, may be observed so well that all the disputes of whether it was made of individual stars or not are destroyed, and we are liberated from the stupid philosophers' wordy arguments. So they love to, you know, kind of tweak philosophers, even as physicists back then. Now, of course, we know he's wrong, because anyone who's ever imaged the Pleiades through even a small telescope knows that there's nebulosity, and that what Galileo is claiming is that you can actually resolve that nebulosity. The nature of the Milky Way was this cloudiness, this milkiness. So he was wrong. It wasn't actually fully resolved. There's no telescope powerful enough to resolve the bluish smudges there into individual stars, because they're not made of individual stars. They're made of silicon and carbon. And here's a Hubble Space Telescope on the lower left. So he believed that he had proven it to be true, because he called it visible certainty in the previous quote. But it's actually the reflection nebula. And even some scientists believe there's actually diamonds in the pure carbon. So it's like twinkle, twinkle, little star was right all along. Now, what was the first thing he decided to do with this discovery? Well, he tried to sell it to his patrons and other patrons in the city-state of Venice. So he went from Tuscany and went over to Venice, and he tried to persuade them to buy it. They didn't buy it really in the quantity that he had hoped, but they allowed him to publish it. And they also made him fully tenured professor of natural philosophy and mathematics. And they doubled his startup. So it's pretty cool from a professor's point of view. We love to have our startup doubled. He thought he'd be famous and go on a book tour and sign copies like Kim Kardashian is doing here. But instead, he was bold and brazen and published a few years later the dialogue, as I said. Again, he keeps touting he's a member of the Lynx Society. It's kind of cute that even this great intellect was so insecure with his accolades and so forth. He had to put it on every book. And he presented it and gave it to the Medici in 1632. The only problem was he was forbidden to do that as you know, he was forbidden to teach, and that was teaching in Italian. So he got into a little bit of trouble with the supremest of supreme courts at the time, the Vatican, the Pope Urban VIII, who had been his tutee under his tutelage, shall we say, his protege. So Galileo tutored him as a young boy and thought he could curry special favors. Maybe they forgot about it, but the Catholic Church doesn't forget very easily. And in fact, they've never fully pardoned Galileo. They've said that he was right. John Paul II in 1987 or so did say that 1992, did say that Galileo was right, but they never pardoned him and said, mea culpa maximus. So here's a depiction of him in the Holy Office. There's a guy with a sword next to him over there. So here's where his prison, quote unquote, was and is, and it's quite a spectacular place. In fact, we had a couple of conferences held there in his villa. It's a stately 20-bedroom mansion with olive trees. You see me in front of the olive trees on the lower right. You just about see the Duomo, the pinnacle of Renaissance architecture, and really the beginning of the artistic, kind of central place that the Renaissance would have, and that being in Florence. So it's an amazing villa to I'm sure Bernie Madoff would have loved to have been in this prison cell. Now, I had a great honor just recently to be the first person to ever make an audiobook, and the first, among the first three people to make an audiobook with a small cohort of people, including Nobel Prize winner Frank Wilczek, director of CERN, Fabiola Giannati, and Jim Gates, who's the founder of superstring theory. So we all read from this book, and it takes place over 4 days, and it's really delightful. You can get a copy of it on my website. And no one's ever done it before. I thought that was a shame, because it's one of the best books ever written, not just the best science books ever written. It's one of the best books. And that's what Albert Einstein calls it in his foreword that Frank Wilczek, winner of the 2004 Nobel Prize, reads, that Einstein said this is unmatched before or since. And so it's quite amazing. So you can find that on my website under my books at briankeating.com. So there are Jim Gates and myself recording this, and you can get all the figures of it. I actually made an NFT of some of the figures just to have fun with it. Hopefully I won't land in jail. But Galileo had all these different mottos, and I love to kind of go through mottos. And I wonder, you guys will tell me sometime if the CAS has a motto. But Galileo had all these mottos, including the Bible shows us the way to go to heaven, not the way the heavens go. I do not feel obliged to believe the same God who endowed us with sense, reason, and intellect had intended us for us forego them of their use. That was one of his mottos. So he's kind of like, being brazen. And there's him looking a lot less, kind of meek in front of the person who would become the Pope in this particular depiction. Now, again, he was wrong. He made many blunders, just like Einstein. I always joke that Einstein made at least 7 blunders, including, what he reputedly called his biggest blunder about dark energy. And that one of Galileo's blunders, and I always say, it's too bad because Einstein could have had a good career, if he didn't make those blunders. But Galileo had the same kind of greatness and the same kinds of blunders. So in the dialogue, the most convincing piece of evidence, according to Galileo, was the depiction that the tides on the Earth's surface are caused by the combined rotation of the Earth and the revolution of the Earth. That those two motions, just as water in a cup of water, or here, if I were to spin this around and rotate it around, maybe you could get some kind of behavior. That's what he called the origin of the Earth's ocean's tides. Totally wrong. Earth's tides are caused by his friend, the moon, on whose surface he discovered the first craters, and depiction that it was actually not unlike mountains and volcanoes and landscapes and plains like the Earth. So it shows you that great minds can be capable of great discoveries, great insights, and great wisdom, and also be completely wrong in other cases. So I like to, discuss that in the context of the Nobel Prize in the book, where I, make the distinction between knowledge and wisdom. And part of the mission of my podcast is to have so many of these Nobel Prize winners on and see if by accumulating their knowledge that they along the way have accumulated wisdom. So I don't only ask them to describe the physics of a Bose-Einstein condensate or of the accelerated expansion of the universe with Brian Schmidt and Adam Rees, but I indeed ask them to get into aspects of their humanity and what drives them and how do they compete and collaborate with other scientists? How do they know when they're wrong? That's one of my favorite questions to ask. What have you changed your mind about in science or outside of science? And it's surprising the candor and intimacy that you get to know somebody when you ask them questions, not only about what they do scientifically. So his third motto, allegedly muttered under his breath, Galileo, was, and yet it moves. So he was right. The earth does move, but the proof that he had was wrong. So he was actually right, but for the wrong reasons. And it's kind of curious why he put so much stock in this. And but he is, of course, a hero to all of us scientists. And really, Einstein calls him the father of the scientific method, not only the first physicist of modern, kind of incarnation, the creator of the first theory of relativity. And he did all this with a small telescope that only allowed him to see stars in the Milky Way. He never saw outside of the realm of of our own galaxy, which is fine and understandable for such a small telescope. And if you fast forward about 100 years, Herschel, Caroline, and William observed the sky, and they too had blunders or mistakes caused by the same types of distortions and biases that Galileo was misled by in the case of the Pleiades, and namely that there are nebulae and there is dust in our galaxy. And they were totally unaware of that. And so that caused them, when they tried to depict where is the Earth in the center or not of our galaxy, Galileo showed we are not the center of the solar system, but maybe our egos would not be bruised so much if we were the center of the galaxy. And so the Herschels, 100 years later, were kind of misled by similar types of illusions. So these are figures from my book, my first book, Losing the Nobel Prize, with a great graphic artist, Schaefer Grubb. And he's showing you that the effect of the presence of dust, when you don't account for dust in the cosmos, either in our solar system, in our galaxy, or in the cosmos, you are subject to many different types of illusions. One is that dust tends to make objects of given brightness appear dimmer. And then since astronomers equate or tend to associate brightness with distance or inverse distance, closer means brighter, dust will reduce your ability to perceive and measure accurately distance if you don't take into account. So the left window has no dust on it, the right window has dust on it. You could tell which one you might think is farther away, even though it's the same spotlight or street light. Dust also, because of its length and the wavelength of visible light, causes light to become both redder and polarized. And that's both going to be important in our study of the cosmic microwave background and the so-called BICEP2 affair. So you are all familiar with this, even if you go out to Lake Erie and you look out on the lake close to sunset. I don't know if you can see it exactly like this. This is taken in the Pacific Ocean. But anyway, you notice that the sun looks redder, more orange, than it does at high noon when you look at it straight above. It looks yellowish green above. Now, the sun doesn't change its color. We know that. It's because of the excess opacity, and the optical path length has more dust in it as you traverse, as the sun goes at higher and higher, larger and larger zenith angle. And that's familiar. And we correct for that as astronomers today. But back then, they really didn't. And not only did the atmosphere cause scattering effects, this one's a little too blurry to read, but it causes microwave light to become more and more red, more and more dim, and more polarized. And this explains the origin of the illusion that caused the Herschels, to misappropriate where the galaxy had the Earth located within it. And actually, we know it's actually located about 2/3 of the way out on one of the galaxy's spiral arms. And that's just like if you're inside of a cloud on a jet going home to Cleveland, it looks like you're kind of inside of a ping pong ball, a spherical ping pong ball. And so it looks like it's centered upon you, even though the cloud could have this weird, classic cloud shape as depicted on the left. Same thing happens in our galaxy, not caused by water molecules, but by dust. And dust also causes the light to become more red, and it causes the light to become more polarized. So here's an accurate depiction of the galaxy. So if we fast forward from the Herschels to the early 1900s, there was a great debate. Is the Milky Way galaxy now the center of the universe? So Galileo disabused us. The Earth is not the center of our solar system. The Herschels eventually, once we corrected for their dust distortion, we knew we weren't the center of the Milky Way. Maybe, please God, can we be the center of the universe? And all we had to go on is the two-dimensional images that we see, and I even have a picture of one behind me over there in my office here. And the question was whether these swirls that look very similar, I mean, the Orion Nebula we know is a nebula, the Whirlpool Galaxy, now we know it's a galaxy. 1923, we didn't. So there was a great debate, and it was resolved by Edwin Hubble, famous Edwin Hubble, who really measured the presence of a type of star called a Cepheid variable in our nearest neighbor galaxy, the Andromeda Galaxy. And by doing so, he could measure the distance to it using Henrietta Leavitt's law, and measure a distance of something like 7 to 10 times the diameter of the Milky Way galaxy. Now we know it's about approximately 2.3 million light years away, closer to 3 million light years away. And so it couldn't be possible that the Andromeda Nebula, which is what they called it, was actually in our galaxy. It's way too far away. So this was a discovery that there are other galaxies conclusively. And then later, when he was measuring these galaxies to make his famous Hubble diagram, he overestimated the expansion rate by a factor of 7, because in part, he didn't take into account the reddening of light due to dust. And so red light exposes more poorly on photographic plates than does white light. And so the reddening of the dust in the Andromeda Galaxy was detrimental to his estimation. And furthermore, the dust also diminishes that light as well. So because of that, he overestimated how fast the universe is expanding. And since the Hubble constant, its inverse is the age of the universe, he got an age of the universe that was 7 times too small. So it turned out that he had estimated that the age of the universe is only about 2 billion years old. And now we know it's about 14 billion years old. And so that was embarrassing, because back then they knew of radioactive decay, and they knew of ages of certain compounds in the earth by the late 1920s that and early 1930s. That meant that Hubble was saying the universe is younger than the objects within it. So it'd be like, you being younger than your mother or something like that. It didn't make any sense. And so it caused people to not believe the Big Bang paradigm for a long time. Again, dust is impacting how we perceive our place in the universe. So that was the Hubble Deep Field. Now we fast forward another 50 years or so. Penzias and Wilson won this prize. There's me holding my book in front of the Holmdel antenna in New Jersey. And they discovered a hiss glowing in all directions that would later turn out to be the cosmic microwave background. Once we remove the average temperature signal in the cosmic microwave background, 2.726 degrees Kelvin, you're left with these faint fluctuations that are called the CMB anisotropy. And one of my guests, John Mather, who is now the chief scientist on the James Webb Space Telescope, he's been on the podcast 2 or 3 times now. He talked about this discovery and what it meant and how close they were to not making this discovery back in when he won the Nobel Prize in 2006. That was for work he did in 1991 and 1992 with a huge team of scientists on COBE. So the question is, how do we explain those fluctuations? And this brings us to what I actually do. There are fluctuations once you remove the mean 2.7 Kelvin signal that are at the level of about 100 microkelvin. So a few parts per 10,000, really, really quite smooth. In fact, smoother than any billiard ball or bowling ball that you guys might bowl with there in Cleveland. I remember going to some lanes out there myself many times. But the explanation of a finely kind of sort of almost tuned universe needs to be explained. Where do those fluctuations come from? That's the science I try to do. So what we're really endeavoring is to explain the imprints, the fossil relics of the cosmos when it was an age of about 100 or maybe 10 trillion seconds, which sounds pretty old, but it really equates to about 380,000 years. I guess it is pretty old, but it's not like trillions of years old. And we're trying to infer from that, what did the universe look like when it was a trillionth of a trillionth of a trillionth of a second old or so? And I always equate that to the universe being like a human being. So on the lower right is what's called a blastocyst, which I always joke is what you look like 1,000 seconds after your own parents had a big bang of a certain kind. Hopefully there's no little kids watching, but nevertheless, then asking, imagine you looked at that blastocyst, you see that picture, and you say, what is this person going to look like? Oh, I know what it's going to look like. It's going to look like Midwestern or native Oprah Winfrey, let's just say. And she's about 2 billion seconds old, which is about 60 years old. And it would be ludicrous to try to do that. And yet that's what we're trying to do. We're trying to basically use a version of what's on the left, upper left, to infer what the universe was like in the lower left. And no one who wasn't crazy would try to do that on the upper right to the lower right, but we're trying to do that. And what we're really attempting to do is go beyond the Pleiades, go beyond the Hubble Deep Field, go back to that modeled image of the CMB and try to divine from it what the universe looked like trillions of seconds after the initial origin of time itself, perhaps in the Big Bang. To do so requires the observation of the least familiar of light's 3 properties. So light has an intensity, a brightness, has a color, but also it has a type of polarization. And polarization is familiar to us. We have polarized sunglasses. So here's one of them. And I could turn it left and right and it'll get darker. My image will get slightly darker, slightly brighter, depending on the polarization. I can take 2 polarizers and I can cross them and I can use them to block out light. So there's 2 of them and I can rotate them and I'll become brighter and dimmer there. So we make use of the cosmic polarization in order to reveal the leftover fragments of the Big Bang. In this case, they're called gravitational waves. They're not exactly the gravitational waves that LIGO discovered and won the Nobel Prize for 2 of my past guests, Ray Weiss and Barry Barish, but they have some things in common. They last forever, they travel at the speed of light, and they are the result of massive objects in violent motion in some context. So in this context, the universe is the most massive thing you could imagine. Coming to existence in a trillionth of a second is the most violent expansion and acceleration one could ever envision. And so there could be relic waves of gravity from that same event. That's what we're looking for. And if true, it'll produce a type of polarization called B-mode polarization. That's what we searched for. To do that, we had to build a telescope. And that telescope had to be cooled down to 454 degrees below 0 Fahrenheit. And it's exactly what Galileo had built himself, which is a refracting telescope. Except instead of his eyes, we use superconducting detectors instead of the retina. And instead of glass lenses that Galileo ground himself, we use pieces of very, very high purity polyethylene, basically the same as milk jugs are made of. And we make a 1 foot diameter, which is a pretty big refracting telescope. If it were made of glass, that would be quite expensive. But these milk jug type materials are quite cheap. But the detectors are incredibly expensive. And the instrument itself is quite massive and has to be taken somewhere very special. So it's about 3 meters tall. It has its own Twitter account, so you can follow it there. And we had to take it to the very bottom of the world, Antarctica. This image came out in the magazine Nature when they reviewed my book in 2018. I think it's kind of cute. Shows cosmologists searching in the heavens for a Nobel Prize, which is somewhat of what my book argues. We took it to the South Pole, which is the dead center of Antarctica. It's the axis in the southern hemisphere that the Earth rotates upon. And so there it is from below, so to speak. To get there, in the past, it was only discovered and reached in 1911. And it was reached by 2 teams within 3 weeks of one another. And that 3-week difference made all the difference of life and death, literally, for the lower team, the British team, who you see, they took a different technological approach to getting there. The Norwegians used sled dogs. And then the sled dogs had a virtue in that they were also much better than people in terms of, just running and not asking questions and not worrying about their loved ones at home. But they could also be eaten once you got to the South Pole. And that's what they did, the Norwegians. The British, with their stiff upper lips, could not make do with eating dogs. So they became the beast of burden on the lower depiction there. And that meant that they consumed a lot more food and fuel, had more rest stops, and 3-week difference that they got their second meant the difference between life and death. They all died. It's still a very dangerous place to get to, as this image shows from my first visit to the South Pole. So, and don't anyone let you, try to get tricked into catching a penguin. They're quite dangerous, and they're not even nice to people. I mean, they're quite violent animals. So don't let their cute disposition and depiction fool you. Here I am taking my Instagram shot. down there. This is the first time I think I went down there. I've been there twice for a total of about a month. It's an amazing place, but it's pretty boring there. The people make it durable and durable, but the landscape is just like shown there, flat, white, no mountains, no animals, nothing but a couple of scientific experiments, and there's ours. And you see in the upper right are these little sticks in the sky, and those are depictions of what the polarization that I told you about would look like if the universe was suffused by gravitational waves, where those waves were caused by inflation. Oh, and by the way, if inflation is true, then something called the multiverse is true. I don't have time to get into that, but suffice it to say that there would be an infinite, potentially infinite number of copies of every single one of us if the multiverse concept is actually true. Again, I don't have time to get into that. But when we made this announcement in 2014 on St. Patrick's Day, it was covered around the world. We claim we discovered and detected that pattern, the very pattern which would indicate that inflation took place. And so there's a press conference at Harvard. There were Nobel laureates in the audience. And there was a viral video from Stanford University, one of the two kind of founding theoretical fathers of inflation, Andre Linde. So hopefully an upcoming guest on the podcast, he promises me. And there he is. And the Stanford, kind of PR team made this video 2 weeks before the announcement. University. And it's pretty glitzy. And it shows my colleague, Xiaolin Kuo.
To Professor Andre Linde, who is the founding father of inflation. So inflation is the theory about the Big Bang. It explains why we have all this stuff in the universe. So today I'm going to tell him our experiment, BICEP 2, based at South Pole, has found the smoking gun evidence of inflation. He has no idea that I'm coming. Well, so I have a surprise for you. Well, surprise signal at point 2. He's coming. Yes. What? Just a second. In this 5 sigma, as clear as day, are of point 2.
So he's telling him that we've detected inflationary gravitational waves.
Point 2 plus minus 0.05.
And they have champagne, and they talk about it. We were on CNN, and we were on every newspaper around the world. I'm sure the Cleveland Plain Dealer covered us as well. But the most important newspaper of all, of course, the San Diego Union Tribune, they covered it on the front page. New York Times, some other small town newspaper on the right there. I like the image at the bottom, The Economist, because it kind of sounds like some guy was just like watching and then, oh man, I saw the beginning of the universe. How cool is that? Of course, you're not really sure you've made it until The Onion debates about you, and they did have a story about us, including whether or not it's possible theoretically to give somebody their heart forever because of B-mode polarization. And there's Michio Kaku, past guest on my podcast. Aretha Franklin, past. No, I didn't have her. I would love to have had her. Diana Ross, Smokey Robinson. So they convened this panel, fictitious panel, shortly after our announcement. And yet, we were always nervous and worrying and wondering, did we actually detect what we thought we detected? Because it was so big that we thought it was basically too good to be true. And again, spoiler alert, the book is called Losing the Nobel Prize. And so you see these housekeepers and they're saying, sure, it's beautiful, but I can't help but think about all that interstellar dust out there. So what does that mean? Well, just as there are meteorites that you can win if you subscribe to my newsletter at briankeating.com/list, so I urge you all to do that. It looks like about 12 of you have done that so far, so please keep those coming. You can also find micrometeorites and even smaller fragments of the failed planets or exploded supernovae that produces this material that I showed you later and earlier rather, and that you can get if you subscribe to the mailing list. Here's a little chunk of it that I keep by my little video recording setup here. And so smaller and smaller elements of this material, it's made of metal. You can hear it when I shake it. And that metal is highly magnetic. And the Milky Way has magnetic fields in it. So actually, if there's dust in the universe, in the Milky Way galaxy, it can get aligned and reproduce that exact same pattern that we were seeking and searching to find, and would therefore ascribe to be the imprint of the inflationary universe. And that's actually what we ended up measuring. So we didn't have this clean, pristine, picturesque view back to the early universe as depicted here by Schaefer-Grubb. Instead, the universe is kind of smoggy, filled with soot. It's a lot like Pittsburgh, isn't it? I mean, it's so ugly. No, I love Pittsburgh, but anyway, we can't be too nice to those guys. And so, but dust is not only bad, it destroyed my Nobel dreams, at least for now, but it also produces the whole planet that we're on, as Carl Sagan said. And I had his widow, Ann Drury, on the podcast, and his daughter, Sasha Sagan, on the podcast. So it's really been a treat to have this podcast since COVID started. It really kept me from going into depths of despair. But Sagan said every saint and sinner lived on this pale blue dot. It's just a mote of dust suspended on a sunbeam. And that's really lucky for us because we have stardust flowing in our veins, as the song goes. We are stardust. The iron in our blood came from a supernova explosion, just like this meteorite did. So we should always be kind of mixed minds about dust. It destroys Nobel Prizes, but it creates planets and people as well. So Nobel dreams blown away in the dust, as all these jokes made at our expense, as I describe in the book. But I was set on a journey of discovery not long after. So after we retracted our claim that we had discovered the imprimatur of inflation, I hadn't really thought of writing a book at that point. But soon after, I got this letter in my mailbox at UCSD, and it was asking me to nominate the winners of the Nobel Prize for the next year. That's kind of embarrassing. It'd be like if Gary asked me to give a talk here. I said, can you introduce me to the Pittsburgh Astronomical Society? That would be really cool. It was kind of humiliating that I was asked to nominate the winners of maybe a prize that perhaps I could have won in 2016. So here's the letter. Don't share it with anybody, please. You see at the upper right, it says strictly confidential. So don't tell anybody. But I've underlined a couple of sentences here. It says work done long ago may be selected for the award only on the supposition that its significance has until recently not been fully appreciated. Then slightly below that, it says candidates in plural. That's interesting. So when I was asked to do this in 2015, I was kind of curious, what exactly did Alfred Nobel want? So I went, as a scholar should, to the original source material, and here's Alfred Nobel's will. This is written a year before his death in November 1895. And I speak fluent Swedish and Norwegian, as I know you all do. So you can read, no, I can't even read his handwriting. But what he says in the translation is that the whole of my estate, all of it, should be given out as prizes every year to those people who in the previous year shall have conferred the greatest benefit to mankind. A portion as followed: 1 part to the person in the singular who shall have made the most important discovery or invention in physics. So now I go back and I look back here and it says work done long ago. Maybe so. Well, that's not last year. That's not the preceding year. It doesn't say one person. It says candidates, plural. This week, 3 people won. In fact, a single person by himself has not won it. And him, unfortunately, there's been only 4 women who've won it in 121 years. But incredibly, they say plural, but Alfred said the single person. And nowhere in this letter does it say that anything to do with conferring the greatest benefit on mankind. So what goes on here? Imagine if you wrote a will and the lawyers and the kids, I don't care what good old mom or dad wanted, we're going to do whatever we want. And we're going to do it for our own purposes. And that's what I've come to realize. That's what the Nobel Prize has done. Now, a lot of people say, Keating, you've got sour grapes, jealous, and I say, look, if you want to see if I'm being honest about the criticism of the Nobel Prize, just get them to offer it to me. And if I don't reject it, then I'm a hypocrite. So we'll see what we can do. Now, I want to give it just a quick quiz. I won't belabor this. There are 3 Nobel-worthy discoveries, but only one of them won the Nobel Prize. And I want you to think, out there, you can raise your hand if you think number 1, the RNA molecule won the Nobel Prize. So raise your hand. I'm watching there on Twitter. Okay, anybody think that? Anybody think that the periodic table? So Mendeleev was alive. He could have won the Nobel Prize. There's even an element 102, I believe, is called Nobelium. It's named after Alfred Nobel. So did that win the Nobel Prize? Raise your other hand if you didn't. Okay. The lighthouse. Anyone think the lighthouse won the Nobel Prize? Anybody not like raising their hand on Zoom? So just raise your hand if you don't like to raise. Okay, a couple of you do. So of course, the lighthouse, invented in the early 1900s. So Gustave Deleuze won it for physics, okay, for automatic gas regulators in conjunction with gas accumulators for illuminating lighthouses and buoys. In 1912, by the way, this was only 7 years after Einstein came up with the theory of relativity. And Einstein didn't win by this time. And the reasons for that had to do with anti-Semitism and other things. But there's been a lot of controversies. Here are 3 laureates that have had great controversy. People have never rescinded the Nobel Prize. People nominated Trump for the Nobel Prize. There was a sex abuse scandal in the Nobel Prize for Literature, so it was canceled 2 years ago. Just incredible that it has so much prestige. There's never been a Nobel Prize retracted, even for outright racists. And like this gentleman, William Shockley, who said that he's basically saying that African Americans should be effectively impeded from reproducing, a form of eugenics. This guy then became the donor to, in San Diego, we used to have this place called the Nobel Prize Sperm Bank, which has been shut down. I don't know if anyone ever made a withdrawal from that particular bank. I hope not. But this guy was a complete racist, and there's been, homophobes and sexists and all sorts of things. No one's ever had their Nobel Prize retracted, unlike the Oscars or Emmys, where it gets retracted. People commit grievous sins. So another bad problem with the Nobel Prize is that it unfairly kind of has excluded women. And so I think that may have started from the beginning, because he gave twice as much money to his nephews as to his nieces. So he had no wife, no children. Alfred didn't have either one of those. So he gave some of his money to his nieces and nephews, but the nieces only got half as much as the boys. So maybe that could have something to do with it. So when I wrote my book, there were only 2 women who had ever won it. Marie Curie in 1903, 60 years later, UC San Diego's own Maria Gephardt-Mayer. She won it in 1963, and our physics department here is named after her. Since my book was published, 2 more women have won it, and I'll get to that in just a second, because I'm obviously responsible. No, I have nothing to do with that. But here's the headlines in the San Diego newspaper when Maria Gephardt-Mayer, won the Nobel Prize. It says, "San Diego mother wins Nobel Prize." That's pretty astonishing that that's how they talked to her. And they talked, and I met her son before he passed away 6 years ago, and he told me that they said even worse stuff, like she was just a housewife. She was far from that. She was a genius, uncovering the mysteries of the nucleus. But then you think things got better. In 2018, one of my colleagues, wives or widows actually, of my colleague, Andrew Lang, she won the Nobel Prize in chemistry. And here was the headline. NASA had the headline: Caltech mom wins Nobel Prize. Son is JPL Mars flight technician. But it doesn't mention the woman, Frances Arnold, who won the chemistry prize. So anyway, as I said, 2 women have won it since then. We've doubled the number of women, thanks to my book. Again, that's just joking. People watching out, wherever you're watching. Donna Strickland and Andrea Ghez, who's a UC LA professor up the road from where we are in San Diego. So that's some progress, but since then, no women have won it again. So we'll see. They'd have to give it only to women for the next 70 years for them to equal the number of men who have won it. I don't think that's going to happen. So a man who didn't win the Peace Prize, but surely deserved it, Mahatma Gandhi, gives some advice. So actually, Hitler was nominated for Nobel Prizes, but Gandhi never won. So he said that we need to be humbler than the dust, seeking after truth, envisioning that dust could crush us. And I thought that's kind of cool. So what do we do now that we know that dust interferes with the cosmic signals we seek? Well, we have to do something to get rid of that dust. And to do that, we've constructed the Simons Observatory, which is on track to be the world's highest and largest cosmic observatory of its kind when it achieves first light or first microwave in 2 years from now, in 2024. It's made up of many, many collaborators from every single continent. Here's what we looked like back in 2019 when we were last together. And just this summer, we had another meeting here in San Diego. I have even more collaborators. It's a huge collaboration. I'm grateful to be the PI of it and running this $100 million project, thanks to donations by the Simons Foundation in New York City, the Heising Simons Foundation in the Bay Area, and our member institutions. So what is it? That's a giant vacuum cleaner stuck out in space. No, it doesn't. People ask me, how can you get rid of dust without a giant vacuum cleaner? Actually, you can get rid of any cosmic signal you want as long as you dedicate an experiment to measuring it. It's called a systematic effect. And so we have dedicated frequencies to look for dust. Remember I said it makes the light redder and redder? So we have channels that can't see the cosmic signals, but can only see the dust. And that's what we're building into the Simons Observatory that we did not have in the BICEP 2 experiment. We have a massive 6-meter diameter telescope. It actually has two 6-meter diameter telescopes, very different than any telescope I'm sure you guys have, not only in size, but in configuration. It has these particular properties that are almost optimal for measuring polarization. It sits in a building 15 meters high, and on my YouTube channel today, I posted a video linked to observations of its first motions about it as a building in Germany where it's being constructed. It'll be shipped to Chile later this year. Now, the detectors are shown there on the upper right. That sits in a camera that's 2.5 meters in diameter. So it's bigger than the Hubble Space Telescope primary mirror. That's just the detector chamber that has to be cooled down to 0.1 degree Kelvin. So almost absolute zero. And then in addition to that, we have 3 smaller telescopes depicted here, one of which is in my lab at UC San Diego. And we're going to measure those. These are kind of analogs of the BICEP 2 experiment, except about 7 to 10 times more powerful, more detectors, colder optics, colder detectors, and 3 times as many telescopes as shown on the right. And they look at dust and they look at the cosmic signals. And from the two, we can distinguish between the polarization caused by dust and the polarization caused by the cosmic inflationary beam modes. We have to go to a very cold site, a very high site. This is in the Atacama Desert. It's one of, if not the highest construction project on Earth at 17,000 feet. You have to wear oxygen masks. There you see it there. It's under construction in this picture. I have some more recent pictures here where this is actually 2 years old now. I should update this. We're pouring the foundation. We have to do everything ourselves. We have to bring concrete up there where everyone's wearing oxygen. We have generators. We have safety equipment. We have to have our own water, toilets. We have to have our own roads, concrete, diesel fuel, diesel power generators. Everything is done by us. It's incredible. We don't get any support from like the National Science Foundation to do any of this. It's all based on the private contributions. So it's going to be loud for a second, but then I'll fast forward. So here's pouring concrete in a snowstorm at 17,200 feet, where the pressure is half of that in Cleveland or San Diego. So it's you have to wear these tanks of oxygen on your back or you'll die or get severe brain damage or chronic pulmonary disorder. So a whole bunch of fun things could happen to you if you don't wear oxygen. Here's a photon's eye view from a drone we have flying over those 3 small telescopes. This about a year ago. It's also not far from an active minefield between Bolivia and Argentina and Chile. They never get along. And you can visit us at simonsobservatory.org. Here's our logo. And I have a lot of videos about that in my channel and Dr. Brian Keating on YouTube. And I describe the origin story of that experiment and the BICEP 2 experiment, and a little bit of a cosmic memoir is what this book is about. There's only 3 chapters, helpfully color-coded in gray. I don't know if you can see that there. So there's 3 chapters about the Nobel Prize. The rest is about the search and the desire to want to understand how our cosmos came to be. So it's kind of a memoir, and it got some nice accolades. But then my wanderings in podcast world led me to write my second book, which is called Think Like a Nobel Prize Winner. So next time Gary's in Montana, you can pick this book up. And this is based on 9 of the 14 interviews I've done with Nobel Prize winners, trying to distill not their scientific legacy or their scientific contributions, but more their life lessons. How do you collaborate? How do you take these lessons if you're, a member of the staff at the at the dog pound there, and you're cleaning up. You still have to work with people, you have to collaborate. And I should say I'm very, very thrilled. One of my graduate students, her father played for the Cleveland Browns back, I think in the 90s and late 80s. And her mother went to Case Western. So cool connection. Stay tuned for her great success. And she'll be on the channel at some point too. So anyway, I'm going to wrap up. There are images and stuff you can find on my website, briankeating.com. Get all my books there. Listen to my podcast. Subscribe to the newsletter. Remember how to do that. It's pretty easy. Just click on that subscribe button. Join the mailing list. You might win a meteorite, and stay in touch. Thanks very much. I have a couple minutes before I have to go babysit for a couple questions.
Brian, thank you very, very much. Very amusing, but also entertaining. And it sounds like you've developed a good sense of humor over the situation. But yeah, I know you got to get going. But any questions for Dr. Keating before he has to go to enjoy the rest of his evening on the left coast?
Well, first of all, I want to say thanks. That was a lot of fun. And I wanted to ask you a question. When you were down at the South Pole, did you happen to cross paths with Chris Martin by any chance?
No, I didn't.
Okay, he was down there working on the Astro Telescope. I don't know
Oh,
if
yeah.
that was.
Yeah, I'm familiar with that.
Okay.
Professor John Rule at Case Western is a close collaborator, and he goes to the South Pole quite frequently.
Uh-huh. The only reason I brought it up is he and I had a project. We were going to take that telescope and actually refurbish it and
Wow.
put it up on the Atacama Plateau
Oh, wow.
as a remotely operated telescope. We wrote the proposals and everything else, never did get the funding, but it would have been a lot of fun. It would have been
That's
cool.
too bad.
Yeah. Well, so I'm familiar with, yeah, you got to wear oxygen.
Yeah, it is an unforgiving environment.
Yes, it is.
I have something. This is Jean Bishop. Brian, I understand that the nebulosity around the Pleiades stars is really of a different distance and a different entirely separate nature. And it just happens to be a coincidence that the two are aligned with our observation at this time. Isn't that so?
No, to the extent in which we know the distance of the Pleiades, which is actually highly uncertain. There are radio measurements done by actually scientists here at UC San Diego that differ from optically derived, parallax derived distances. But the light, most of the light that I showed around Merope, which is I think in the lower left as we were viewing it, it's associated with the formation of those stars themselves. So there are, kind of, from reflection nebula, you see the same spectrum of if you take a slit and you put it on the nebula only, you get the same spectral characteristics as if you put it directly on the star. So that would indicate it's very close in proximity.
There was a professor at the University of Toledo who made the announcement that they were of different distance, but you're using the similarity of elements in the two, at least one star and one part of that nebula. Is there any chance that other parts of the nebula are at different distances?
Well, I mean, again, the nebula, the Pleiades themselves is quite large. I mean, it's many, many times the distance of our solar system to the Oort cloud. I forget the actual distance, but it may be, several thousand AU in diameter. So to say that any one star is exactly located at any, in the exact same nebulosity envelope may not be so controversial as you might be thinking about it. But no, I mean, it would be a heck of a coincidence to be spatially localized, chemically identical, spectroscopically identical, and not be, and just be a random coincidence. I can't imagine how that could occur, but I would have to look at this particular announcement in more detail. As I said, the actual distance is uncertain at the level of several parsecs to tens of parsecs at the few percent level, which is quite large by parallax standards.
Thank you. Thank you.
Anybody else? Okay. Dr. Keating, we greatly appreciate your time. Thanks for hanging out with us this evening. Virtual round of applause for you, sir.
Yes.
We look forward to getting your digital literature through our varied internet devices. But thank you for your time. This was a really fun talk.
Thank you.
Speaking committee, great job in reaching out and getting another great speaker for our October meeting.
Okay.
Brian, if you're ever in Cleveland or ever planning on coming to Cleveland, let me know. Maybe I can get you in front of about 300 people at BW.
Oh, I would love that. Yeah. For now, I put my link to my mailing list in the chat, and my YouTube channel is available there too.
Cool.
Okay.
Thanks,
Cool.
guys. Been a pleasure.
Thanks, everybody. Y'all have a great night,
Thank
everyone.
you very much.
Bye.
I know.